All right, let's go ahead and do 9.1 correlation. So we're going to use those scatter plots that we talked about. You can see one on the screen here with all of the dots all over the place. And then we're going to look at whether there seems to be a pattern there. So a correlation is just that there's a relationship between two variables. So we're again going to use those ordered pairs, x, y. We're going to have an x-axis and a y-axis. Now we might only use one coordinate of that for our scatter diagrams because we want everything to be positive. And so we might actually just use quadrant 1 here. We'll just see as we go along. So x is the independent variable. It's also called the explanatory variable. And so that's what is explaining what's happening. And y is going to be the dependent variable. All right, so we have a few examples here. You can see on this top left example, as x gets larger, so as we head further to the right on the x-axis, the y is decreasing. So we have negative slope. If we were to draw a line through these points, that would be a line with negative slope. And so we actually call that negative linear correlation because those dots are almost in a line. They're a little off, but they're almost in a line and they're headed in a negative direction, meaning that as x gets bigger, y decreases. Now on the next one, on the top right, we have the opposite. If we were to draw a line basically connecting these points, we would see that it has positive slope. So as x gets bigger, as we head to the right on the x-axis, y also gets bigger, y increases. And so we say that this is a positive linear correlation. Now down here on the bottom left, that's just a mess. The dots are all over the place. There's no trend at all that we can see. And so we're going to say no correlation. And then this one on the bottom right, we are not going to do this one in this class, but that's actually a parabola, which is going to be negative x squared. And so this is a nonlinear correlation. Again, we're not going to really be looking at these much in this class, but that does happen quite a bit, just like the data we're looking at right now with the COVID-19 is starting to look like a logarithmic curve, which is what we usually see with like the flu or the H1N1. And so it kind of looks like this. It's not a line. And so we also have ways to analyze that. Okay, so here we're looking at the gross domestic product of a certain country. And so our X's are in trillions of dollars. And then we're looking at the CO2 emissions in millions of metric tons, and that's our Y. So in theory, you would think that the more money we spend as a country, the more carbon dioxide emissions we have because we're buying more cars, we're buying other things that use fuel. And so that would be an assumption from the start. If you took the data and graphed it, which is what they did here, and they put it on this graph, you can kind of see an upward trend. It's not perfect. It's not a perfect line, but no data is going to be perfect. But you can see that it's basically headed upward. And so we're going to say that as the gross domestic product increases, the carbon dioxide or the CO2 emissions also increase. All right, so this is a study where they wanted to look at the number of hours a student exercises per week, so that's X, and see if that had anything to do with their GPA. Probably hoping that the more they exercise, that helps their GPA go up. And so they grabbed data for these students, and so X is the hours of exercise That's going to be down here on the graph. And then the y is the GPA over here. They plotted the points, and look what happens. There's nothing there, right? There's no trend. The points are all over the place. You can't see an upward trend. You can't see a downward trend. There is nothing. And so we're going to say that that they do not appear to be related. All right, so I'm very happy to say we are not going to do this. Don't panic. Don't panic when you see this. StatCrunch is going to take care of this for us. We're going to put our data in. Actually, the data will come in on its own from the problem. But we are going to look at what's called a correlation coefficient. And what this is going to do is this is going to help us see the strength of the correlation between the two variables. So we can eyeball it and see that the data looks pretty good and it's very close to a line, but R gives us just a better picture of how good of a correlation we have. Again, that is going to be calculated by StatCrunch. Okay, so let's look at these one by one. So let's first look at the top left corner. So we plotted these points. It's the number of adult movie tickets and then the total cost. And you can see these are right in a line. Like all of those data points are perfectly in a line. Not going to happen in real life. But if it did, we would say that we had perfect positive correlation and that R is equal to 1. So 1 is going to mean perfect positive correlation. Now, if you go to this next one, you can see on the next one to the right, this time we have height in inches and shoe size. So the data is a little more mixed up. You can still see that there's definitely a trend, right? You can see that you're headed up if you drew a line through these data points. But it's not perfect. It's not like that first one, but it's pretty strong. And so they're telling me that R is 0.81. So pretty close to 1, but not quite 1. And so we would say a strong positive correlation. Then this last one on the first row, we have income per year and amount spent on milk per year. So this one's kind of all over the place. Not quite enough to say no correlation, but if we drew a line on there, you can see there's a lot of data points off of that line. And so we're going to say that this is a weak positive correlation. We can still see that it's positive, but it's not very good. And so we have R equals 0.45. And so at that point, you might want to go look at some different shapes to try to get this data to fit together, or maybe you're looking at the wrong data and you need to look at a different variable. All right, so let's go to the bottom row. On the far left, on the bottom row, you can see that these are exactly in a row, but they're headed downward, right? And so we have a perfect negative correlation, but R is -1. That's because it's headed in the negative direction, like negative slope. The next one here is pretty good. There's still some points off of the line. And so we're going to say that there's a strong negative correlation. It's still headed downward. This is the number of absences versus the test grade. In other words, the more absences you have, the lower your test grade. And so R is equal to -0.92. So still pretty strong, but not quite 1, so not perfect. And then finally, this last one is all over the place. Like, I mean, you could almost put it in an S, but that's not a function. And so we're going to say no correlation on this last one because the points are all over the place. And also, R is equal to 0.04. It's almost 0. And so that is going to be deemed no correlation. Okay, so again, I just wanted to show you this data. We are not going to do this calculation. Don't do all this. You're going to use StatCrunch. But they did give me the data we looked at on that other slide, the gross domestic product, and also the CO2 emissions. We are going to bring this into Stat One more time, I'm going to tell you, don't do this. Don't do this. We are going to use StatCrunch. So let's look at the next screen of how we're going to use. Okay, in part two, we are going to look at a little bit of hypothesis testing, but I wanted you to see here that we are going to look at the R, the correlation coefficient, and we are going to compare that to our level of significance. And so that's going to be in part two. Actually, I said that is going to be in part two, but it looks like we have one right here. So let's take a look. So we know that from this problem, we know that n is equal to 25. It says I used 25 pairs of data, that my R was approximately 0.979. That's pretty strong, right? They want to know, is the correlation coefficient significant? And we're going to use alpha equals 0.5. So this, we are going to use the table that is given with the problem. I think I have an example in part two that we're going to take a look at. But based on, they told me that alpha, the significance level is 0.05. So when I go to the table here, I have to look at two things. I have to look at the significance, which is 0.05, is this column in the middle. I also have to look at my n. So for me, since my n was 25 and I wanted the significance level of 5%, my critical value is 0.396. And so what I'm going to do is I'm going to compare these two. Okay. What happens is if my R is greater than my critical value over here, then the correlation is significant. Now, the only thing is, if R is negative, you do have to find the absolute value. So remember, the absolute value, if I have the absolute value of -5, that would equal +5, right? Absolute value is distance, and so it would always change it to positive. So I'm checking here, I'm checking my R versus my critical value for a 5% significance level. Since R is greater than the critical value, I'm going to say that the population correlation is significant. Therefore, I can say with a 5% level of confidence that this strong linear correlation is good.